Can you see my face, by the way? Okay, one second. Okay, thank you. Hey everyone, this is Eric Chen, co-founder and CEO of Injective Labs. So today we're going to start talking about Ethereum Scalability, DEX, and DeFi. And I think this is specifically applicable for Injective's case because we are a decentralized derivative exchange that's order book based and built on top of Ethereum, trying to scale a lot of transaction issues and economic issues that are sitting on top of Ethereum with regards to DEX. And specifically derivative DEXs in our case, and for the greater DeFi. So it's actually not the first time that Ethereum had a scalability issue in terms of gas price in an absolute sense in Gwei. Basically during the crypto kitty around kind of early 2017 or late 2016, we had a giant spike in gas cost. And this kind of caused basically a negative externality for the entire Ethereum ecosystem and creating a very, very high gas, albeit at that time Ethereum was not that expensive to acquire. It still created a very interesting phenomenon, and we kind of saw how the community reacted to it in terms of dealing with the scalability issues on Ethereum, and also for the greater ecosystem and how the greater blockchain space reacted to it when it comes to Ethereum's gas costs and also block time. But one thing we started noticing is that it basically creates an interesting dichotomy because back then there was basically a quick reversal in terms of gas costs, and it relatively stayed stable after that single incident. But this time it's drastically different. While we don't see a very major spike in gas price after this, we still see a consistent growth in gas cost. And basically, what was the reason behind this? And the answer is fairly simple. It's because of DeFi and a greater DEX ecosystem. So right now, if we take a quick look at the DEX volume, it's been basically dominating most of the Ethereum transactions. And it has created a lot of value extraction, value accrual. So during May, we saw an all-time high in terms of Uniswap volume, which is 59 billion. And total DEX volume to be around 162. So there's an 85,000% growth over the year. And obviously this entire phenomenon is fairly new to the average user. We don't really see a major dominance in transaction for DEXs within Ethereum until 2020. So this is extremely interesting because right now we see around 3 million unique addresses trading and engaging in DeFi out of the 58 million of address in Ethereum. So this is basically a 13x growth over the past year. And we see Uniswap total users to be around 1.53 million users. And taking Compound as a lending protocol, for example, which doesn't require that much active trading, which has a lot more quote unquote value per user, it still has 316,000 users. And even for daily DEX volume at the peak, we saw 3.3 billion DEX volume with 1.98 million unique addresses on a daily basis. So even right now, we're still seeing a lot of fees going through Uniswap, and the daily volume is still around 700 million. I remember back in May, the average Ethereum transaction fee, basically beyond just a standard ETH transfer or standard ERC20 transfer, is around $43. And at the peak, Uniswap transfer did hit around, I believe, to be $60 to $100, which is pretty crazy. But this isn't the first time that front running and minor extractable value has occurred. So back in around 2018 or 2017, the 0x protocol and also Ether Delta had a similar issue, albeit on a lower scale. 0x Relay and also 0x protocol settlements are able to be front run. And this is especially the case for any type of cancellation transaction. So taking in the case that you are a market maker, your trades are effectively under the danger of being captured by some arbitragers if you don't cancel your order fast enough and pay a high enough gas fee. So the standard 0x model works is that you can place an order and sign with a certain relayer or a certain approval, but cancellation requires an on-chain transaction. So that means that you can create stellar liquidity on the order book for a 0x exchange. But in order to respond effectively to the price, you would have to pay the cost of updating the order book and replacing it. So this kind of creates an interesting economic, because market makers would have to completely deviate from a traditional market making model. You don't just market make on a standard exchange being able to place and cancel thousands of times per second. And you have to be extremely mindful of the economics of order book quoting. So this kind of creates a perverse incentive where market makers want to quote wider and less frequently, and kind of create more quality slots. So this way it prevents people trying to hit a bad fill and trying to create a sandwich attack. But this creates an issue where liquidity becomes a lot less competitive on order book DEXs. Basically, you're going to we start seeing orders that are being quoted at a very significant premium or discount with a very, very large spread. So this way, at least during the price movements for a on-chain Ethereum block of 15 seconds or 2 minutes, market makers have that safety of cancellation, won't be able to put them into a bad price position. But with poor liquidity comes basically poor volume and poor user experience, and kind of created this negative feedback loop. So this is also one reason why 0x protocol and also back then the on-chain settlement, off-chain relay model never really reached the amount of volume or quote-unquote adoption that we see today with AMM DEXs. There were solutions at a time, of course, and there were a couple of really brilliant writings done by the creators of 0x protocol on dealing with front running and the perils of and virtual settlement. And so one of the pretty safe approach back then was creating a TEC model, where essentially you get to soft cancel and just placing more trust into the relayer so that the relayer handles the cancellation for you. Another way to deal with this is obviously what we constantly discuss today and what became the canonical or dominant discussion that we see, which is layer 2. Even back then, there were already ZK Rollups, the discussions around it. There's already Plasma. So it's really interesting to see how everything played out to today. So here's so Uniswap came along and kind of created this very Ethereum friendly type of exchange model. So basically the mechanism design is honestly pretty brilliant. So there's a liquidity provider and there's an arbitrager. And in order to keep a liquidity provider making money, all the fees from the arbitrager or any type of trading fee will go to the liquidity provider, basically in a short volatility stance. And on another hand, arbitrager will consistently gain these quick arbitrage spreads, essentially marking a profit for every single trade, so that every single on-chain transaction has an expression of itself. So this means that as a liquidity provider, I'm automatically market making on top of the liquidity pool. But at the same time, arbitrager is also making sure that the price of the liquidity pool actively reflects basically the global liquidity, while receiving even profit that's greater than the 0.3% in exchange fees and also gas. And obviously V3 kind of changed a lot of the math around it and kind of complicates a lot of the aspects of LPing and also arbitraging. But I think the general rule of thumb still stays. But the problem with AMM is that it kind of exacerbates and kind of augments this entire issue around competition for transaction ordering and also competition for transaction inclusion. While back then it was basically people trying to snipe a few cancel orders, and market makers can be smart around basically making sure that their order isn't being sandwich attacked. In the AMM's case, it kind of became an auction, or it kind of became a gamified element where essentially there's a profit window and everyone is trying to bid for the inclusion or for the opportunity to make this arbitrage profit. So this is why we started seeing, the term minor extractable value coming out, and Phil Diane and a few others from Cornell also created a lot of work around flash boys and front running. Even last 30 days alone, we saw $9.1 million in extracted MEV, 400,000 in extracted MEV in the last 24 hours, and total MEV to be around 761 million, which is a pretty scary number. But the interesting part here is that it's mainly gas auction because it's a sender income rather than miner income. But the total wasted fees on failed MEV TX's transactions is still 12.5 million, which is pretty crazy. So why should we care? So first of all, this seems like a pretty natural ecosystem when basically a lot of these profit windows and a lot of these transactions are getting more and more profitable. It's a demonstration more as a growth of an ecosystem and a growth of participants. But basically it creates a negative externality for fees, because while there are DeFi transactions that are highly profitable, that kind of attaches a value and allows people to bid, in a net positive cost basis. Ethereum is not only just about DeFi. There's also NFTs. There's also a lot of different other elements. There's also basic token transfer, and basically, because of the way Ethereum consensus works, all these transactions are going to have to pay the premium and pay a significantly higher gas cost than other layer ones to be able to basically satisfy the same use that Ethereum DeFi is using. And on the other hand, during the market volatile events, gas costs will be extremely high because there are liquidation auctions almost, and there are also arbitrage gas auctions. This kind of creates another issue where basically the entire industry have to strategically place their transfer, or the use of Ethereum has to be modeled around basically the trading and the DeFi aspect of things, which is essentially demonstrates, kind of like naturally agent-based ecosystem, but ideally we can do better than that. On the other hand, the convenience of Uniswap and kind of this instant swap model does bring a lot of users to be more accepting of going through the AMM model, going through on-chain transactions. But any type of unsophisticated market transaction does create a profit window for arbitragers, which is kind of which is a good thing for arbitragers, but not necessarily the best thing for the overall capital efficiency of the greater market. But it kind of brings back the question of whether this is a scalability issue, because at the end of the day, even if we create a larger and larger throughput, it doesn't necessarily mean that this problem is going to be solved. It's because the transaction auctioning model itself is kind of creating this a competition around gas. And long as the Ethereum ecosystem grows at the same pace of the scalability of Ethereum, the gas cost is going to stay relatively the same. Simply because as the Ethereum ecosystem grows, as more and more liquidation and more extractable value comes in, no matter how big the throughput is, it just might create a bigger auction, or more sophisticated auction, and any type of gas fee will still spill over to the average user. So while it does help to have higher throughput, and it might be a temporary solution, but as Ethereum grows over time, it might not necessarily be a long-term solution. So when we start seeing Ethereum transaction costs going higher and higher, and we start seeing basically gas auctions and arbitrage transactions dominating the Ethereum mempool, how did the community deal with this? So first of all, we kind of see the blossoming of other alternative Ethereum layer ones like BSC, like Phantom, like I mean maybe not even layer one that's EVM compatible like Solana. So there's a very natural move for people to kind of move their token off of Ethereum or move their transactions or needs off of Ethereum. But as we see now, basically, eventually all the values still rest on Ethereum. It's kind of like it's almost like a spillover stadium within like a large game like the Super Bowl, where the users are coming in here mainly for the Super Bowl and not necessarily for the tailgate party on the parking lot. Obviously, they might complain on Twitter, but there's also a lot of, it also encourages a lot of gas optimization designs within Ethereum smart contract. Back in the day, there used to be a lot of pretty brilliant innovation around gas token futures. Obviously, right now, it kind of created almost like a negative externality for the overall gas fee, and we actually saw an improvement of gas fee after, deletion of storage gas refund is removed. Another thing is Ethereum 2.0 will have a sharding solution. And so this means that it does help a lot in terms of scalability and also removing this kind of negative feedback loop with gas option. But it's keep getting delayed, so we'll wait and see. But I mainly want to kind of shift the focus around the dominant discussion of this talk, which is layer 2 solutions. Basically, it's going into production more and more. Every single project that we're seeing is going into production. It's finally going live on mainnet. And we start seeing a lot of significant adoptions, a lot of economic values resting on these layer 2 solutions. And more interestingly, we start seeing basically layer 2 solutions having a very, very serious discussion in terms of adoption, usability, and user experience and centralization / decentralization risk. So while basically gas auction might be removed by layer 2 solutions, we want to kind of compare how they work and whether they can be the perfect solution for everything that we're dealing with in DeFi. So a quick glimpse into layer 2. Why is layer 2 a thing? So basically there's a few like fundamental principles around layer 2. Obviously it's a very, very broad thing, and there are various levels of, or schools of thought when it comes to what defines as a layer 2. Does sidechain count? Does like a layer 1 with a independent or like a fully decentralized bridge count? Does a POA sidechain count? So I would say that fundamentally, if you want to go down like a more strict sense, layer 2 is essentially resting the security or the ultimate security on Ethereum while maintaining the transitory state elsewhere. So this means that basically for any type of layer 2 solution, in a strict sense, layer 2 should be having Ethereum as a final source of truth, and basically only maintaining the state between every Ethereum block or between every checkpoint to be maintained elsewhere. But eventually, all state is going to be verifiable and settled on chain. So the most obvious example in this case would be ZK and Stark Rollup. Basically, it uses recursive start to basically maintain off-chain all the in-between information, but basically it's going to be every single transaction that's being submitted to the ZK Stark or ZK Rollup or Stark Rollup operator will be a Stark or Stark proof will be produced and immediately verified on chain. So it is a pretty promising solution, and we do see a lot of support from Matter Labs and Stark. We're working on this diligently. But right now, there's still not a full EVM compatibility or a smart contract suite, which is why it kind of produced Optimistic Rollup, which does support full EVM or OVM in this case, with a lot more smart contract composability and kind of a very natural and easy deployment for any type of existing Solidity contracts. So obviously, people are working on Optimistic Rollups like Optimism, and Arbitrum, and both of them are actually going into production. So the way Optimism works, and I'm sure since there's already people from Optimism here at this talk, I'm just gonna probably just let them kind of cover it more in depth. But the interesting thing here is that basically it operates in more of a optimistic sense, obviously, where basically a transitory state is going to have an operator, and there's going to be a verifier and disputer. And in the case that the operator's not producing these transactions or verifying these transactions fairly, basically there's a bonding, there's a stake or a bond that's going to be removed, and the entire chain is the entire transaction is going to be replayed on Ethereum almost. And so this kind of allows for basically an issue where the withdrawal period has to be confidently long, so that people can actually be able to dispute it and bring the transaction history on chain. So generally, for Optimism's case, it's around 7 days, and I think this is mainly fine because there are mitigating solutions such as optimistic Optimism futures, where essentially you can create a futures around this token that's going to be exited and basically pay a small slight premium for tokens that are kind of currently awaiting withdrawal. And XI is actually a pretty interesting innovation in the sense that they kind of went with a POA consensus and completely have an independent chain that doesn't rely a checkpoint per se on Ethereum. So this type of sidechain model actually is very natural for developers to build on top of, mainly because it has basically unrestricted EVM compatibility. And more importantly, it has fairly strong scalability, and it has a very malleable and flexible consensus that can be improved over time based on developer needs. And we started seeing Perpetual Protocol and a few others building on top of XI and basically generating very impressive volume, even though it's not sitting on Ethereum. We also see a explosive growth of Polygon. A lot of projects are basically deploying the exact same contracts, or completely new contracts, as a matter of fact, on top of Polygon. And the way Polygon works is that basically it's a fork of Cosmos initially that has a basically dual chain model where there's an EVM layer where all the transactions are going to be sitting on top of that, and basically there's also going to be a bridge. And generally, right now Polygon is using a POA or a multi-sig bridge that transfer also state over. But they do have also a Plasma bridge with a Plasma predicate, but we don't really see a significant adoption around that. Usually what we notice these days is that developers generally prefer to just go with a full EVM compatibility and going through a relatively more centralized bridge. For Injective's case, basically we built this fairly interesting innovation around the way how bridges work. So Injective is actually kind of a triple layer solution where we have this order book layer that's fully Cosmos native with a keeper and query model. We also have later on an Ethereum layer with EVM compatibility. And we have this bridge component where essentially it's backed by the validators of Injective, but the consensus and the operation of it does not rely on Ethereum whatsoever. So this kind of creates kind of like an independent consensus, again, with ease of improvement over time, and we can upgrade Injective over time towards whatever the community needs. The most interesting thing here is that basically all these three layers interact with each other. The order book layer has an internal bridge between this ETH to Injective bridge and also to the EVM layer. So this allows the position of Injective to be exported to the EVM layer and vice versa. And more importantly, it can be also exported down to Ethereum as a representation of any type of derivative position, which we do expect to be heavily utilized over time as more and more people build on top of Injective. But currently, there's a lot of nuances within the layer 2 sector, and I kind of briefly mentioned about it. So, for example, Optimistic Rollup versus ZK Rollup, which one is better in terms of developer friendliness? Which one is going to gain significant adoption? Although on a lot of metrics, ZK Rollup do appear to be more superior in terms of TPS and in terms of basically trustlessness and in terms of security assumptions. But what we do see is that optimistic rollups can get to market a lot faster with the full EVM compatibility, or in their case, OVM. And we do see that optimistic rollup can be a lot more developer friendly compared to a ZK rollup, which you basically have to encode every single logic or rewrite your entire Solidity contract. But does that matter over time? Do you think one question is that Matter Lab is working on something with full EVM compatibility, and Starkware is also working on something like that, similar as well. And on the other hand, Optimistic Rollup does have TPS constraint, and it does have it kind of like a slightly higher gas cost compared to ZK Rollup. And as a result, Optimistic Rollup also has not as fast finality compared to ZK Rollup, which creates another interesting comparison because ZK Rollup don't really have that 7-day withdrawal period. But another issue is that these layer 2 sectors, a lot of them do rely on a centralized operator to be able to maintain these states, to be able to kind of keep track of their transactions. ZK Rollup doesn't necessarily have to per se, but in order to get the full transaction history, in order to generate the proof in a fast and secure way, it still requires a central operator. And in most of the production cases, we do see for the layer 2 projects, they are relying on a single server for this. And we do see progressive decentralization steps towards trying to remove this single operator model. But currently within the broad production environment, most of it is still relying on a single server. But the good thing about most of these layer 2 solutions is that it is trying to work off of a trustless basis. So that means that basically most of you don't have to trust the central operator. You don't really have to trust that centralized operator because eventually people are going to verify it, it's bonded, or the proof is going to be submitted immediately on chain. But obviously in the sidechain and also independent chain cases, you have to trust the validator or basically the economic and consensus security of those chains. But generally, as the user of those platforms, the trust kind of tied together. But it kind of brings in another major problem overall is that it creates this lonely island of composability, because the beauty of Ethereum is that basically every single DeFi project is composable with another. You can basically create this entire money Lego and build on top of each other and create atomic transactions and very, very interesting flash loan attacks to kind of bundle all this DeFi stack together. But as we see right now with the blossoming of multiple layer 2 solutions and seeing so many scalability solutions coming out, is that individual projects either have to deploy to all the layer 2 solutions, and that is under the assumption that they can, or they would have to sit within their own layer 2 solution and face this kind of partial composability with all the other protocols that are currently sitting on the same layer 2 solution, or basically it will result in a congregation of all projects sitting within the same layer 2 solution, which actually might face the same scalability concern that Ethereum was facing in the first place. So the Lonely Island issue is going to be a pretty significant issue as we start seeing projects trying to move into more interesting and nuanced layer 2 solutions, and how we see composability is going to play out. Vitalik has worked on very interesting work about making transactions between layer 2 solutions, but currently we still haven't seen anything in the production environment yet. Another interesting thing is that, again, like I said previously, that there's a blossoming of alternative EVM layer 1s when we start seeing a huge competition around Ethereum gas and gas auction. As we can see, BSC was at one point having a significantly higher transaction volume than Ethereum. There's a lot of other layer ones like Solana and Phantom also blossoming and bringing a lot of projects on as a result of Ethereum's congestion issues. But is that going to be another viable approach compared to the current growth of layer 2 that we're seeing? So first of all, this relies on two assumptions. Number one is that layer 2 is generally a trusted solution. It is decentralized eventually, whereas alternative EVM layer 1s is decentralized to begin with. But the decentralization aspect of it is different in the sense that alternative EVM layer 1 has this test on the consensus strength and also the decentralization of the consensus, which a lot of the alternative layer 1s are trying to kind of forgo in terms of decentralization in exchange for higher throughput or just in general fancier features. But I think generally for the user's case, this is something for them to be mindful of when they're evaluating whether to move their assets over or whether to turn that into a go-to avenue for any type of DeFi or on-chain transaction. Another interesting consideration or thesis of layer 2 is that it's completely ETH reliant. Basically, the consensus of a sidechain or Optimistic Rollup or ZK Rollup or any type of other layer 2 solutions or state channel are resting their final state on Ethereum. And any state updates or any change on the layer 2 level doesn't matter in the long run. But alternative layer 1s is relying on a set of validators or a set of participants that have strong economic stake in the layer 1. While both of these are have their kind of considerations, because when you try to do ETH reliance, you generally require a compressed set of state, or basically the state transition to be sitting on Ethereum eventually. Validator reliance kind of rests this state to be custody or beholden by a set of validators that are, albeit decentralized, if done properly, is still not part of Ethereum. Another thing is chain consensus. Like I said before, the strength of the consensus and also decentralization of a consensus is very key when it comes to evaluating this versus a layer 2 solution. And how the bridges work. This is one thing that we've been noticing very recently, is that most of the bridges across chains are generally POA, or has a significant centralization factor embedded within it. It either has a multi-sig as a fallback, or it has basically a multi-sig that's signing off every single deposit and withdrawal. And this creates an interesting problem because bridges between chains shouldn't be decentralized, or it shouldn't be in a pure POA model. And we do start seeing, for example, Gravity DEX going live with their Gravity bridge. Bridges are basically fully decentralized, and basically the users can trust a decentralized set of actors that are academically bounded rather than a multi-sig set of actors that does have a corruption risk. And another interesting thing is that while we don't see a lot of projects moving on to layer 2 at this moment, mainly because most of these projects are just starting to go into production, we do start seeing a lot of projects going into sidechain solutions or alternative layer 1s. So a lot of projects, for example, Aave has already built on top of Polygon, and a lot of major projects have already moved to Polygon. So this kind of brings into question whether composability by setting all within the same chain, such as Polygon, matters, or does a congregation around basically multiple layer 1s, layer 2s matter? And this is kind of like a in progress type of discussion that we're going to see play out as more and more developers pick their avenue and see how it works out. And the last part is basically for the alternative layer 1, you're not really trusting the contract on Ethereum, you're trusting your chain. And this kind of creates a lot of attack vectors, and obviously building a chain, as we know from Injective, is not the easiest thing. And basically the lack of auditing solutions for layer 1s is a concerning factor. Considering Ethereum, for any type of Solidity or EVM base, you can always go to an auditor and they can give you a rough estimate or guesses of the attack vectors and the risk factors. Although it's not a perfect solution, it is certainly better than a lot of layer 1 auditors out there, just because of how custom or how bespoke the chain is set up versus Solidity. And another interesting thing that I haven't really touched on previously is the centralization risk of layer 2 is not only a risk in terms of security, but also a risk in terms of regulation. When you are hosting something, when you are an operator for a DeFi protocol, when people deploy some DeFi or exchange project on top of you, does this flag you as kind of like a centralized operator in the eyes of the regulator? This might be an issue, but obviously we haven't seen any court cases being tested or any type of real challenges yet. But from what we've seen before and from what we kind of noticed in terms of the pattern of regulators, this could be a potential threat for the adoption of layer 2s. Okay. Yeah, sure. So basically, injective approach, kind of mentioned before. Injective has an order book model, and basically order placement and also order cancellation is highly optimized. Long as basically the mempool is relatively empty, it doesn't require any cost, and overall, it's one of the lightest transactions within a chain. Since we are an independent consensus with a malleable kind of governance, we're no longer limited to on-chain throughput and scalability compared to other layer 2 solutions. But that being said, trust is relied on injectives validators, which we've tried to curate over time amongst the testnet phases and everything. And we try to maximize composability. First of all, like I said, basically all positions are being exportable. And also currently, the most interesting thing is that all these positions can be created and tokenized and kind of transferred in a certain interesting way onto Ethereum and basically creating an entire blossoming DeFi protocol. And another thing is that the only auctioning mechanism that Injective has within the overall derivative model is the liquidation incentive. So basically people are auctioning and bidding using a more superior price to capture a position that's under liquidation rather than paying for gas, which essentially causes a negative externality for clawback. But yeah, basically we previously explored a few like firm running protection solutions, such as utilization of VDF, and actually went down a pretty deep rabbit hole around it. But we decided to go with a more blockchain sensible model where essentially basically within the stateful nature, within this kind of the nature of blockchain where there's no time between every single state or there's no explicit concept of time, we decided to go with a batch auction model. And essentially, given the model of Cosmos, we decided to put matching and the clearing and settlement at the end blocker, and thereby kind of creating this entire interesting, very blockchain advocate model of matching rather than a continuous double auction. But yeah, like this is all the moving parts around Injective. Unfortunately, I don't have, unfortunately, due to time, I can't talk about every single one of them in depth. But yeah, if you guys have any question, feel free to ask me. Thank you so much. Bye.